Hello everybody. It's a pleasure indeed for me to be here today in the Indian Institute of Chemical Biology to give the CSIR Foundation Day lecture. As was mentioned, I am no stranger to your lab. I have been here in times long before many of you were probably, some of you even born. So, director said that CSIR has survived 80 years. He used the word survived, by the way. And I can say that I have survived Indian science for 40 years. So, both CSIR and I have both survived. And we are still, by grace of God, very much alive, and I am able to come and talk to you today. Now, I will please request all the people to switch off the cell phones and ideally switch the phone off itself. Why do we need these cell phones? They have only spoiled our lives. Really, beyond a point, they're okay for certain things, but the moment that cell phone dominates you more than you dominating the cell phone, then somewhere sanity goes out of the window. So, what do I want to talk to you about today? Many things actually. I have about an hour. And I don't give platitudes. And that's part of the reason people like me, and also part of the reason people don't like me. Let me say that this surviving thing, the CSIR surviving, or me surviving, or anybody surviving, anybody who survives as opposed to anything that collapses, learns how to adapt with time. Anybody who has a fixed idea of things, fixed idea of life itself, they don't survive. So it is a trite to say that CSIR is changing. CSIR is changing, no doubt. Our country itself is changing. And it is changing very fast. And this is a special message, I would say, for people in Bengal, which has had a very good history, say 100 years ago, and where people are more conscious of history than perhaps in other parts of this country. Being conscious of history doesn't mean that you worship the past. The idea of change must come naturally. And the country is changing tremendously quickly. Now, I have observed most of my life. I turned 70 just less than a month ago. And except for the 6 years when I was in America, the rest of my life I have spent in India. Okay. And I have still survived. That's why I tell all you students, all the fellows and girls who are running away to America, England and all, wrong. Today what is happening in Leicester, what is happening in Leeds, what is happening in Toronto, they are actually coming and beating you up and killing you. Please think about all this before you run for that foreign postdoc. What do you get there? Okay, you get a training. I have had some brilliant postdocs in my lab. And many of these people, of course, they got their PhDs in India, they came to me, they got a job after that in India. What is wrong with your own country that you feel like running away to Toronto or Oklahoma or Tulsa or whatever, some funny places? Today it's actually come to the point where we are going to be number 3 in PPP terms by about 2040, at a time when many of you students will be in the prime of your life. By about 2047, we may actually, with a bit of luck, be number 3 in absolute money terms, not just PPP. So this is the whole enterprise which I call now Bharat, which is the subject of my latest book. It was not written just out of the top of my head, because I have seen science at close quarters in India at least for the last 25 years and been a part of decision making. And I can tell you this country is veritably changing. This is not just some political talk and some mentioning some party line and this line and that line. I am the least interested in political parties. The country is changing because the people themselves want to change. And colonialism or decolonization, whatever you want to call it, this is a special challenge for Bengal because the shadow of colonial rule fell very heavily on you people compared to other parts of India. I grew up in Madras and Bombay, which were both metropolitan cities of the British, but I can tell you that the colonial thing is much greater in Kolkata than in Madras and Bombay, definitely, without a doubt. I am familiar with all these 3 cities now. So this is something that decolonization is something that you actually have to do. And let us hope that in the course of my talk, I have chosen, it doesn't matter what the subject is, but I have chosen Mendeleev. And specifically the periodic table and how this notion of intuitive thinking as opposed to intellectual thinking came to the forefront in science. This intuitive thinking is something which this country is particularly strong because our ancient scriptures actually formalize this whole business of intuitive thinking. Not that we don't have intellectual thinking, but Mendeleev was one of these people who actually used this intuitive thinking, which is why he cracked the riddle of the periodic table, which was one of the biggest scientific problems which was facing chemistry and science in his time. So let's begin somewhere. There is some story before Mendeleev. Then there's Mendeleev himself, what he did. After Mendeleev, and I certainly hope to spend 5 minutes or so at the end of the talk talking about the periodic table and today's geopolitics. Don't forget, science is not some ivory towers, some funny people wearing white lab coats and going inside there and doing something and coming up with some molecules or some proteins or something like that. Many people started asking me, I've got lots of friends outside the scientific side. They said, what are you scientist fellow doing something, writing a book on the constitution? No, you scientists. I said, what are we scientists supposed to do? Sit in the white lab coats and do something? No, we'll do that also. But this is also my constitution. It's your constitution, everybody's constitution. We are all stakeholders in this country. Stakeholders don't run away to America. I went to America, I got my PhD there, I got a job there, I got a green card when I was 24 years old. I gave up that green card at the age of 26 and came back to India without a job. How many of you will go to America and after 40 years be asked to come to a major US university and give a talk like what I am giving today? If you can do that in America, then go there. If you can't do that, actually you're better off being here, because this again is this country that's growing now. So this country needs people. It needs people like you. And there is also something in it for you. It is not just some one-way sacrifice that you are making. You got to use your brains. What has God given you brains for? You come up to the point of passing exams and doing a PhD. You got to use that brain, no? But because all your friends are going to Alabama, you also want to go to Missouri. Irrational and illogical. So geopolitics, I want to talk a little bit specifically about this group of compounds, elements called rare earths. Before Mendeleev, briefly, let me say, there is a period of antiquity, ancient times. Then a few important names like Lavoisier, Boyle, Dalton, Canizaro. And about as far as antiquity is concerned, these are certain ancient elements. They have been known to mankind from the beginning. Copper was the first one that was isolated in pure form by man. And they say that the earliest native copper was found almost 8,000 years ago. Copper is ancient element. The other things are also equally well known. Chemists will recognize that many of these elements are very low in the electrochemical series. So that means they are quite easy to extract from the ores. Many of them, like gold and all that, occur in the native form itself. Gold is one of those elements which is stabler in the native form than it is in the form of its ores. Our ancient scriptures also talk about it. The Namakam Jamakam of Sri Rudram says, Hiranyam Chame, Ayas Chame, Shisham Chame, Trapus Chame, Shyamam Chame, Loham Chame. All these metals are described. Gold, silver, lead, tin, iron, copper. They are all given as oblations to Rudra. And scholars have talked about the meaning of these words. Does IS really mean silver or not? Loham definitely means here in this context copper. It is a red metal. So we knew about these things also. Phosphorus is one of the first that was discovered isolated as a pure element in Germany. So this very great man, Antoine Lavoisier, I would say he is probably, in my mind, the greatest chemist who has ever lived. And this is a bold statement because there have been many great chemists. But he is the person who said that there may be so many elements and so on. He didn't even know what an element was, but there were things like iron, copper and stuff. People knew these things. Oxygen is the element that reacts with practically every other element. So it provides a calibration of the oxidizability or reducibility of particular metal or its compounds. It's a calibrant. So the properties of every element are measured with respect to oxygen. Oxygen is the calibration. See, hello please, I don't like people leaving the hall. You should not have come in the first place. Okay? Now you can go. It's very bad for the speaker. Those who come should be here. If you don't want to come, don't come at all. ऐसा वैसा आना जाना अच्छा नहीं है. Please think about the speaker. See, I am a teacher finally. So I am not in a I've taught in a university. CSIR lab, you can't do all these things, I guess. Most of my students take my comments quite nicely. So, coming back to this guy, the electrochemical series that I described is described with relation to oxygen. Something like potassium gets oxidized very easily. Something like lead gets oxidized very slowly. So that gives an idea of the reactivity of metals itself. And I often like to say, gold they say is a sort of a kingly element, used in the crowns and all that. Gold is, you can say, President of India. Oxygen is Prime Minister of India. Oxygen knows all the other elements. It can control all the other elements. President of India, we know what President. Nice, she lives in a nice palace and all that, but that's all. It's just like gold. You can't do anything with it. Same. So, actually two very famous chemists, Roald Hoffmann and Carl Genesi, wrote a little play on oxygen. It says that since we are coming to the time of the Nobel Prizes, so it's worthwhile to talk. They said, suppose oxygen was discovered today, who would have got the Nobel Prize for the discovery? So like that, it's a very amusing drama and it has been played also. I wish somebody were to play it in India or maybe in Bengali also. It should be done. This is how I think people should get more and more familiar with all these things. Dalton, I can say, atomic theory, he actually started giving some names, hydrogen, oxygen, blah, blah, blah. Now this guy is more important, Canizaro. By that time, people had, the only thing they knew in chemistry in those days was gravimetry. They could weigh, they could burn something, they could weigh it before, they could weigh it afterwards. That's all that they had. So he developed what is called atomic weights. And he says that the atomic weight of an element is the least weight of it contained in a molecule. So it's a measure of the mass of the element. They knew, they were getting an idea that there is some small thing called atom inside and all that. So what is the weight of this? So he developed, then this led to the biggest, as I said, the chemical riddle of the periodic table. People started realizing that some of these elements had properties that were similar to other elements. Potassium, lithium, sodium, calcium, copper, silver, gold, nitrogen, phosphorus, arsenic, antimony. They had some relationship, not exactly very clear what this relationship was, but there was a relationship. The case of the halogens is especially well known. Chlorine is a yellowish gas, bromine is a reddish liquid, iodine is a purplish solid. A very sort of a demarcation of the properties. And people were wanting to know what is this about these elements? Why do some of the properties keep recurring? Is there some pattern? Will the atomic weights give you an inkling about this pattern? So people started ordering the elements in terms of atomic weights to try to see if anything came out of it. There was one chap in England called Newlands. He said Newland's law of octaves, he said. Just like octaves, there are 7 notes in the musical scale. He says if you arrange the elements in order of atomic weight, the 8th is the repeat of the first, the 9th is the repeat of the second. Now this worked for some time. It works for lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. They didn't know neon, of course. Then they came to sodium, calcium, etc. Just next row, third row. So there they found for 2 rows this law of octaves worked. After that it broke down. They had many sort of interesting ideas. Typical scientific problem. You got some data and you try to analyze and find a pattern. This is what we all do all the time. We try to do. So this is what they were trying to do. And in this situation came this great hero who was a wild character in Russia, which was itself a wild place in those days. He was actually from Siberia. He was a very rich man. He owned large farms and all that kind of thing. So his major business was running all those things. Yesterday I heard that Rabindranath Tagore was a very successful and wealthy zamindar, and he had a very good practical sense of running his family's large estates all over Bengal. And at the same time, he was a literary person of the highest caliber. Mendeleev is a bit like that. He was running a successful dairy and cheese business actually, as part of the farms, large farms that he had. And he used to worry quite a lot about that, and also worry about his periodic table. This problem was really bugging him. Then he tried the same thing that everybody else was trying. He tried to organize these elements in atomic weights to see the pattern. And these are some of his later scribblings in the original Russian. So you can see he did all sorts of things. You can see certain elements and all that, so many things he has written. This was towards the end of his story, and this is now written in a form that we can read and understand. You notice hydrogen equals 1. There was no helium in those days. Lithium equals 7, he says. Beryllium is 9.4 years old. Boron equals 11. Carbon equals 12. These correspond quite closely to today's atomic weights. And you notice that there are certain things, very interesting things here. He says question mark equals 68, question mark equals 70, he says. Sometimes he puts question mark ER equals 56. What are these question marks? And then you look. This is also very interesting. 116, 118, 122. Then he puts 128 question marks. And then he puts 127 after that. So the one with the higher atomic weight he puts first, and then the lower he puts second. So what is all these things going on here? What are those question marks? That was the intuitive thinking. What Mendeleev did, the story of Mendeleev and getting to the periodic table itself is extremely romantic. He was supposed to go to see the cheese farm, and the cart came, sled came, it was deep winter, to take him to some station or something. 3 times he sent away that sled because he was getting to the final answer about all these things. Because there was another guy in Germany, his competitor called Lothar Meyer. Lothar Meyer just took the atomic weights and just put it in order, and afterwards said there is no pattern. Doesn't work. It breaks down. Now, like suppose if you were to put iodine before tellurium, then iodine will look like oxygen, sulfur and selenium, which it doesn't. Only tellurium looks like oxygen, sulfur and selenium, and then you will have tellurium with fluorine, chlorine, bromine. Tellurium doesn't look like that. So only by putting the higher atomic weight first, you get the matching with oxygen, etc., and with fluorine, etc. So Mendeleev did 2 very bold things. The first thing is, in certain cases, he inverted the order. In other cases, and this is, I believe, his greatest contribution, question mark equals 68, question mark equals 70. What is all that question marks? It looks like there is some unknown thing with the atomic weight of 68. And yes, in Mendeleev's time it was unknown. And then what he did was something even more bold. Look at this, what we call now the blue, scandium, and look at that gallium. Aluminium, scandium, gallium. Aluminium was known. Then he said, that question mark equals 68. I'm coming, this is the story. He said there will be an element with atomic weight 68. There will be. With these properties, with density 6.0, melting point low, valency 3, oxide will have a formula of EA2O3. So he was predicting properties of something that was not known at all. And he was a great aficionado of Sanskrit, so he called it Eka aluminium. Like aluminium, something will be formed. And a few years later, this Eka aluminium was found in France. It was called gallium. And the chap who found out gallium, he measured the properties and he found that his density was coming lower than what Mendeleev had predicted. So he wrote a letter to Mendeleev and said, I think I got Eka aluminium, but your density is wrong. Mendeleev replied him immediately. He said, no, my density is not wrong, your experiment is wrong. See what he is able to say. Usually we scientists it's an article of faith for us that experiment comes first and then interpretation comes after that. He said, no, your experiment is wrong. So that guy went and he did something, what he did. Then he wrote another letter. He's saying, Professor Mendeleev, you are correct. My sample was impure. When I purified it and then I did the density, I got your density. Now this is what I mean by intuitive thinking. What is this intuitive thinking? The best way of understanding this is by just looking at this picture, colored picture. I'll say no words, but I'll just tell you this is the proof of Pythagoras theorem. I'll give you 10 seconds to just look at this picture. It is from Vedic mathematics. And the explanation given below is just a single word. It simply says, behold. So all that complicated construction that we learn in Pythagoras theorem, that similar triangles proof, all that is not required. So when you see something like this, the proof comes out straight out at you. Radhakrishnan says this very well, and I quote from his idealist view of life. The true test of knowledge is certainty, which is a characteristic of intuitive thinking, rather than communicability, which characterizes intellectual knowledge. This is profound. When we write a paper, when we send something to a journal, we are mostly interested in communicability. We take a result and then on the basis of earlier facts, blah, 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 the data, you come to some conclusion and then I say because of this happened and therefore this happened. And therefore this is what my story is. That is intellectual knowledge which we do all the time. What does Radhakrishnan say here? He says the test of intuitive knowledge is actually certainty. That means you have read so much. Mendeleev had read everything to know about the elements. And at some point, eureka moment or whatever you call it, suddenly a flash occurred to him. Arey Baba, there are elements that haven't been found. That is why we are in such trouble. And then he said, atomic weights were accurate. But he also figured out that atomic weights was not the answer. And that is why he